Hello guys, so we are going to continue the series with respect to feature engineering, and in this video we are going to talk about handling imbalanced dataset. Now, why should we handle the imbalanced dataset? What exactly is imbalanced dataset? We'll discuss about this. It's just to make you understand some of the things over here, but later, when we are developing projects, we'll be seeing all these things, okay? Now, with respect to any problem statement that you may be working in machine learning and deep learning, initially, you will be given a data set, right? Now, let's say there is a data set, and let's consider that you are trying to solve a classification problem. Now, whenever I say classification, supervised machine learning problem, that basically means the output is basically in the form of categories, right? If you have two categories, we will say it as a binary classification. So let's consider this binary classification for an instance to make you understand what exactly imbalanced data set is. Let's say I have 1,000 data points in my data set. Okay. Now, with respect to this 1,000 data points, the output feature is basically a binary classification problem. Let's say my output can be something like yes or no, right? Now, out of this 1,000 data points, let's consider that I have 900 yes and 100 no data points, right? Now, this scenario, you can see that the maximum number of data points are basically saying yes, and there is a very minimal number of data points that are probably saying no. So if you probably see the ratio, so here 9:1 ratio is there. This kind of situation basically talks about an imbalanced data set, because out of the 1,000 data points, you have 900 yes and you have 100 no. What is the main problem if you have an imbalanced data set while you're solving a machine learning application? Your model that you may get, you are probably creating, which will be responsible in predicting, will get biased towards this maximum number of data points, right? Because of the imbalanced data set. So it is necessary that we fix this imbalanced data set and we try to make sure that both these data points become equal. And we can do this. There are techniques. There are two special techniques that we will be using. One is called as upsampling and one is called as downsampling. Okay. Now, when we say about upsampling and downsampling, this is just like in upsampling, we try to increase the number of data points from here, which is basically minority. In downsampling, we try to reduce the data points from here, which is majority, right? So now we will go ahead and show you a problem statement over here from a code, like how we can basically do it. So here it is. So clearly here you can basically see that there are two techniques, upsampling and downsampling, right? First we'll perform upsampling and then we'll perform downsampling. Now, first of all, let me create that specific data set. So for that, I'll be just using some code, okay, which I have already created. Now let's understand this code. I've imported NumPy and pandas. And then here you can probably see that I have also imported this np.random.seed so that whenever I'm randomly selecting some values, it should not change. Okay. Then we create a data frame with two classes. Okay. First, I'm taking 1,000 data points. Just for instance, you can take 10,000 data points also, not a problem. I'm saying that my class 0 ratio is 0.9. That basically means 90% class 0 ratio. And when I talk about this number of class of 0, that basically means I will have 900 data points. So what I'm doing, I'm multiplying this 1,000 by 0.9. So here totally I'll be able to get 900. And remaining will go to my class 1, which is basically my other category. So total 100 data points will come over here. So if I probably execute this, now you'll be able to see that if I write n_class_0, comma n_class_1, right? If I execute this, I'm having 900, 100 data points. Okay. Now this is very much clear. Now what I will do next step is that I will create my data frame. Okay. So I will create my data frame with imbalanced data set. Okay. This is super important, with imbalanced data set. Now for this, I'm again pasting one code. Now this is a technique of creating a data frame with two features, feature 1 and feature 2, which is a normal distribution. This is also a normal distribution. This is mean, this is this. How many number of data points I want with respect to class _0, that will basically give me this 900. And over here also feature 1 will basically generate 900 data points, and target, the 0 will get multiplied by 900 data points. That basically means 900 zeros will get created in this class 0 data frame. Okay. Similarly, in class 1 data frame, I'm basically taking 100 data points over here. And similarly, I'm using this 1 as my target output 100 times, right? So if I probably execute this, and if I probably write pd.concat, sorry, I think I've used caps lock. So if I write pd.concat, and inside this, let's say that I am combining this class underscore 0, comma, class underscore 1. Okay. And along with this, I will also reset my index, because when I'm actually trying to combine this, I will be getting one index value. So I want to drop this also. So reset underscore index with drop is equal to true. So once I do this, I will be probably getting my df. So this is my df.head. Okay. This is my df.head, and this is what I'm actually getting. If you probably see df.tail, I will be able to see ones over here. And if I really want to see the value counts of target, so you can probably see over here, if I write target dot value underscore counts, you'll be able to see that I'll be getting 900 and 100 data points. Okay, it is up to you. You can create any imbalanced data set. You can also have 10,000 data points and 900 data points, something like that. Okay. Now, the first technique, I will probably be using something called as upsampling. Now, in upsampling, what I'll do, I will try to increase this number of ones to 900. I'll create some artificial points, and that is what upsampling does. So in case of upsampling, as said, upsampling, okay, what I'm actually going to do is that, first of all, I'm going to create two data frames. One data frame is with respect to df.target, where my target is double equal to 1. Okay. So this will basically get me all the rows whose target is equal to 1. And you know that when 1 is there, that is my minority class, right? So I'm going to create my df underscore minority. Okay. Now, similarly for majority, what I'm going to do, I'm going to basically write df underscore majority. Okay. Majority. Okay. And this target will basically be 0. Okay, so I've segregated this because I need to increase the number of minority over here. Now we will be using one library which is called as from sklearn.utils. I'm going to import resample. Now resample, what it does is that this basically creates it extrapolates the point. That basically means whatever point is minority, right? It will try to create more new points for this, and it will try to equalize with respect to the majority. So resample, first parameter that we specifically give over here is something called as df underscore minority, like for which sample I want to probably perform upsampling. The next important parameter is something called as replace is equal to true. Replace basically means that whenever I am performing the resampling over here, okay, whenever I'm performing the resampling, this sample that will get added, it will get added with replacement. So different new data points can be added over here. Okay. This was with respect to my second data point. Then how many I want to increase? So for that, I will reuse n underscore samples. And here I will write length of df underscore majority, because I want to increase that much, right? 900 data points. So this is the next one. And then I'm going to use random underscore state, any random state value, so that the seed is fixed over here. And this I will save it in df underscore minority underscore updated or upsampled. Now you will be seeing that whatever df underscore minority underscore upsampled is there, this shape will be 900 data points. Okay. So that basically means I have actually created more data points over here, and all this particular data set is basically giving the output as 1. If you don't believe me, just write dot head and see you're getting 1. Right? Now what we can do, we can again use pd.concat, and now we can combine df underscore majority along with df underscore minority upsampled, and then you can see the output over here. So this is my df underscore upsampled, right? Perfect. So here I'll execute this, and now if you see df underscore upsampled with dot of target of value counts, now you will be able to see how many data points, 900 zeros, 900 ones. So that will be total 1800, right? So value counts. And if you probably see the output, so here I'm getting 900 zeros and 901. This is how upsampling is done. Now, if I probably consider downsampling, so in the case of downsampling, I'll be using the same code of creating the data set. Okay, the same data set, I can probably use it. For that, I'll just copy it, which I already have my data set over here. Okay. So let me go ahead and copy it over here so that you will be able to. So in short, I'm creating the same data set over here, whatever we did, right? 900 zeros and 900 ones. Now, with respect to downsampling, what we are going to do is that again, we are going to use everything same. So this same code will be there. Like upsampling, we'll try to create like this. So downsampling also, first of all, we will create downsampling. All the steps will be same, guys. So I'm directly copying and pasting. So I'm creating 2 data frames, and now I will use df underscore majority, right? So I will use the same library. Now, instead of writing minority upsampled, here I will write majority downsampled. I'm just giving one name. Okay. And the first parameter will probably go with df underscore majority. Let's see, majority, yeah. Replaced will not be true now because we need to reduce the data points, right? So this sampling with replacement will be removed because we want to reduce the data points. And this n underscore sample will now be the minority one because I want to reduce the data points to the length of the minority, right? So once I do this, so now if I probably see df of majority downsampled dot shape, you will be able to see 100,3. This is what the size is now. It has got reduced, and you can probably see over here. And finally, what I can do, I can probably combine like this and just write df underscore downsampled. So here I will write downsampled, and this will first of all go with the minority df underscore minority, and this will be df underscore majority downsampled, right? Let's go majority downsampled. So here we are basically downsampling things, right? So, okay, one error is there, not a problem. Let me see. Okay, this one square braces is missing. Okay, so now if I write df underscore downsampled dot target dot value counts. So here you'll be able to see I'll be getting 100 data points. So this is how we can do downsampling. Downsampling is bad because we are losing data points. We can probably do upsampling and probably try to solve this particular problem whenever we are trying to train our model. So I hope you are able to understand about handling imbalanced data set. This was it from my side. I hope you like this particular video. I will see you all in the next.